specializing in healthcare. Our speaker, David Taubey, is the CTO of John Snow Labs. John Snow Labs is a company specializing in helping healthcare companies using AI to help democratize AI in healthcare industry. Now let's welcome David Taubey.
Thank you, everyone. Can you hear me well? Great. Okay, so my goal today is to help you understand kind of the early findings and where we are today in terms of applying large language models in healthcare. What are the initial findings in terms of accuracy, speed, benchmarks, and what you should consider in terms of first case studies and first actual uses we are seeing in the field when you go and build your own. So I'm from John Snow Labs. John Snow Labs, we're the company behind Spark NLP, but we do a lot of work in the healthcare field. Majority of the large pharmaceutical, large academic medical center, a lot of health IT companies use us to understand clinical notes, biomedical research, voice of the patient. And always, the focus has been on accuracy, right? So we said we productize research, and so our main promise to you is we will give you state-of-the-art accuracy at any given time. And what it meant was, for example, in 2022 and the years before, state-of-the-art accuracy meant that we had these peer-reviewed papers, and we achieved new state-of-the-art accuracy for tasks like name entity recognition, relation extraction, extracting adverse drug events, right? And those are kind of the NLP tasks, and they're kind of well-defined accuracy benchmarks in the clinical and biomedical NLP spaces. 2023, as with everyone, the world has changed, right? And it's definitely the year of the LLM, and a lot of the interest, a lot of the focus has been in that space. And really, one of the questions was, okay, if our job is to give the industry, the open source community, the state-of-the-art models, but are we switching to this now? What can it do well? What can it not do well? Because if there are tasks where LLMs now give us better accuracy than the deep learning, transfer model, learning model, zero-shot models that were there before, then that's what we need to provide. And a lot of our focus has been on some of really evaluating those tasks and seeing how well we can do there. So right now where we are, there already is a lot of work on healthcare-specific, on medical large language models. And those models do show a promise in terms of a far higher accuracy in terms of benchmarks on anything from medical question answering to kind of the classic NLP tasks. This is one example. The BioGPT model was released by Microsoft Research. When it was released about 4 months ago, it achieved new state-of-the-art accuracy for PubMed QA, so answering biomedical research questions. That's one of the first models we embodied in the software, right? And that's just part of the software we give. One of the first questions was, especially when GPT-4 came out, is like do we even need this stuff, right? And this is an actual academic paper, and it's a very valid question. Okay, so for 30 years, there were separate academic journals, separate conferences, separate workshops on clinical NLP and biomedical NLP, right? Because it's a different language, different set of problems, different set of benchmarks. And the question was, well, can we just do it all with one big GPT-4 model? And people, academics have actually tried it on a whole set of benchmarks, and the categorical answer is no, you cannot do that. Right now, it definitely seems that those models, the new GPT-style models, including the latest and greatest one, are far below where they need to be in terms of accuracy for most of the classic information extraction, clinical information extraction tasks that kind of the clinical biomedical NLP community has been interested in. This is something we are seeing now in other industries as well. And there's growing understanding, yes, we're going to have legal-specific LLMs and finance-specific LLMs, right, and healthcare-specific LLMs, and even maybe more than one. But that was really one of the first questions. So let's talk about healthcare LLMs and what's available today. So we set out, and that's a healthcare NLP product. There's now really more than 1,200 models that you get with it out of the box, and we keep updating the models every 2 weeks. And they do clinical entity recognition for more than 400 entities. They do relation extraction, they do de-identification, they do summarization. And really the question was, okay, the LLMs, they're good for something. Obviously, they're good for tons of things. They're pretty amazing. Let's see which tasks We want to replace some of what we have here with a new generation of better, stronger models. The most commonly used models in the industry are ones that extract information. So I have a patient note, and I have questions like, it's a pathology report, and I want to know, tumor staging, histology, biomarker, right? It's lab results. I want to know what are the abnormal results. It's a biomedical research paper. I want to know, was this a clinical trial? What stage, what outcome metric, was this combination therapy, how many patients of which demographics? We've missed one. So we've run our own analysis, and all of this, you have the link here. Everything I'm showing you in terms of benchmarks, by the way, they're all public, meaning the Python notebooks are public. We ran this on data, these kind of academic data sets, with the goal and even the hope and the request that you will reproduce this. Let us know if you don't like our metrics, if you don't like our benchmarks, if you have other data sets, if it works differently in your own private data sets, please tell us. That's the whole point of learning from each other. But here's what we have seen. We've seen the models we already have on really basic tasks like clinical entity recognition, so just finding out things like symptoms, diagnoses, biomarkers, social determinants of health, diseases, medical devices. The ones we have already make about half the errors that the ChatGPT does. In terms of normalizing entities, so resolving to ICD-10 codes, RX norm codes, SNOMED codes, LOIN codes, right? So really being able to normalize text into standard medical terminologies and terms. Also, there's significant gaps there. And even in terms of de-identification, which you would think would be an easier task. So far, really, as much as we played with different prompts and different different combinations of a way to do it right, really, we're just kind of a combination of kind of classic deep learning and rules you can do really far better. And de-identification is really one of those really already solved problems where you can get to 99% accuracy in real world data. And it seems like really this is just, this is what you want to do. And then this paper came out, and I was really happy with it because I still wasn't sure, are we the only crazy ones who are saying, look, this stuff actually does not work and is far less accurate, because it obviously works beautifully for tons of real-world use cases. But then this paper came out about 3 weeks ago and basically said the same thing. So this is a group of academic researchers that also tried to look at also ChatGPT, GPT-4. I think they also tried one of the open source ones that was available at the time on several of the classic biomedical NLP benchmarks that have been studied and compared on for the past 10 years. And they compared it, really what they found, they compared it to PubMed BERT. If you're familiar with PubMed BERT, it's about 3 years old. It really is not state of the art anymore in terms of what you get, right? It's pretty basic. It's not what you go to production with today. And it's significantly outperformed with really F1 scores that are, a 20% difference in F1 score means that one model makes 5 to 6 times more errors, right, than another model, right? So it's not even something that's close or usable. And that's where we are today. So not information extraction. So the next question was, okay, so maybe there are other tasks or other features where you do want to use LLM, and there are definitely other ones. And that's what we ended up doing, adding. So one of the first things we did, we trained BioGPT JSL, which is it's based on BioGPT. It's a question answering model. The big difference is that this is a closed book model. So with BioGPT, you have to actually give it the context, right? So you can say, here's the medical paper, answer questions from this paper. And what we did here, we can say, no, just memorize the entire internet. I just ask you a question, they give me an answer. Okay, but obviously it's not the internet, it's specifically trained on medical research, so it does not answer from Reddit, those kinds of things. Another thing, if you're in this space right now, if you're following the latest EU AI Act, one of the things you have to be able to report to do is provide a transparency report, right? So, okay, which data did you actually train this on? Make sure you do not steal the data, make sure the data is actually valid and correct. So we want to make sure that is in place. So question answering is definitely one interesting use case, and you can ask questions as a medical professional. You can also ask questions in different tones. So these are kind of questions asked by patients. Okay, and patients, we know they use very, very different language, different words, different jargon, bad grammar in a different way. But this is something that LLM actually do really well. They'll be able to understand different tones of speech and give you the correct answer. Another pretty popular case study is generating synthetic content. Okay, and this is something that LLMs are really just built for. Like if you actually want it to hallucinate, yeah, it does it beautifully, right? So if you come and say, like, I need a patient, she needs to be 87 years old, she needs to have this recurrent type of cancer, she needs to have a history of, hip replacement and hypertension, and, if you want, you can give her one more thing, and just give me, like, 4 pages of the latest discharge summary. Okay, these are things that, you can do really well, and that's now also, it's part of the library, it's available out of the box. You really just need to tune it on healthcare. And by far, the most popular model and most popular feature is around text summarization. Okay, and text summarization is simply the task of take a bunch of medical text and just give me less of it. This is something that's really used, I would say, really all over the place. One of the problems with electronic medical records today is really they just contain too much information. Okay, so I'm your patient, I come to you, you're a specialist. You look at the EHR, you click around, or I can even give you, here's a printout, here's 300 pages of me in the last 6 months, and you look at it, and you say, okay, just tell me everything from the beginning, right? Because you have 15 minutes with me anyway, right? And because you need the documentation for billing and quality and other things, there's a lot of copy-pasting, there's a lot of junk. Okay, so being able to summarize and really be able to take 3 sentences. Who is this person? Why are they here today? So what's the chief complaint? What did we do to them, and what's the plan going forward? Is something that you really want to extract from clinical notes. And then there are other summarization models that are interesting. For example, the ability to summarize biomedical research, right, to summarize PubMed papers. Okay, one of the known problems is that really there's just too much medical research, right? This was very obvious I think in the COVID times, at the height of COVID, there was like 200,000 related COVID papers per month. Okay, but even if you're a super specialist, it's one of the things, like in the 1950s, if you were a heart surgeon, you could literally read all the journals, everything that was published on heart surgery, okay, in 2 Saturdays at home when you sit, you sit with your journal. Okay, today really you just don't read even 0.1% of what's there. So there's a problem of just doing semantic search and be able to find what's really what's going on. Another separate LLM that we've tuned specifically was to summarizing patient questions. So patient question is just patients, they speak in a very different way. I was diagnosed with this, and then this doctor gave me this and referred me to the other, but then I found this on Google, and my sister told me this, but my mother told me no. So what do you think I should do? Okay, and you have these very long-winded stories, and really the challenge here is really, okay, what is the actual medical question, and you want to summarize it in one sentence. And really, it requires annotating data, doctors, right, tuning, making sure the right information is there. And we've even gone to more specialty-specific models, right? So we have, for example, radiology-specific test summarization, right? Because radiology, the specific questions you care about. And one of the challenges, if you use kind of what's called state-of-the-art text summarization models that are general, is that they just miss some of those facts. Okay, like what was the critical finding? What's the gender of the patient? Why are they even here? And you want to basically tune models that know how to do that. So these are public benchmarks. We've published them. We published the notebooks. We published the data we did it on with the sole purpose of enabling you to come and say, well, my data is different. Yes, like please test and let us know what you find, and we can tune. But we tested this against BART, against FLENT5, against Pegasus, kind of the current highlights of text summarization models. And we looked at ROG scores. We looked at BLUE scores. We also have our own medical doctors to actually look at the data. It's really where you start. And there are definitely very significant gaps. And it's not really surprising. It's like anything in machine learning, if you tune to a task, if you tune with specific data, right, if you're a domain expert, you're going to see better results. The only thing we're seeing with LLMs, we are seeing the exact same thing. You're going to have very, very big gaps in accuracy between different types of models. So definitely when you are tuning your own LLMs, you definitely healthcare-specific content, healthcare-specific tasks, and start there. So everything I showed you far, that's kind of just part of our kind of models and product. Yeah, it comes, right? If you use Johnson Labs, it just comes with it, and you have those models. And if you're a Python data scientist, you can put all of that in place. But now, really the cool thing about LLMs, and especially the chat-based LLMs, is that you don't need to be a Python data scientist to put this thing together and put them in pipelines, right? And really what you want is you want to have this nice chat application, and you want an end users to be able to ask questions, right? That's the whole point, right? That instead of emailing a question to my team of SQL data analysts, I just email it to a chatbot and it just replies to me automatically, and that just happens, right? And someone does the translation. And we're building this kind of application that specifically for the healthcare space, and you have the chatbot and the backend, and you can ask it medical questions, and it retains context, and you can ask it with specific knowledge bases. And when we started, really, of course, the first question was, okay, like why do you need a healthcare-specific one? What would be different in healthcare? And when we talk to customers and prospects and people who are really trying to solve these problems, really it comes down to three things that people really don't want. One is no data sharing. So it comes and says, look, you see this in healthcare, you also see this in legal. Comes and look, this needs to run behind my firewall. I'm not sending data to anyone. I'm not sending questions to anyone. I want this to run completely within my control, right? Because if I need to send you patient data because I want to ask questions about my patient, there's PHI that I need to share, and now it's going to all kinds of places that I'm not sure about. So we want to do everything to run in a very encapsulated, basically air-gap environment. Right? This thing should be able to run without an internet connection. The most important thing was like what we call the no BS principle. You cannot hallucinate. Okay? So if you're a doctor and I'm your nurse and you ask me, oh, well, what did you give this patient? And 90% of the time I tell you what I gave this patient, but I'm so eager to please 10% I just make stuff up. It means that I'm completely useless to you. It means that 100% of the time you have to double check my work. Okay? So you have to make sure that an answer is a real answer that we can back up. Okay? And that's just completely a given in any of the use cases we've seen. The third important thing, and I think the first two are pretty well known. The third, I don't think people talk about it enough, is the responsible AI piece. In general, in life science, in healthcare, but if you're doing something in biotech, you cannot go to production with the model if you have not tested that it performs the same way on white people, black people, on men, on women, on people with diabetes, without diabetes, people who are pregnant, people who are not pregnant. Okay? If you do this, you're doing something that is illegal. Okay? You will get sued. Okay? And it can even go beyond that. Okay? And for good reason. Okay? So we're in other industries, all the other industries right now, yeah, just take it to market, have people play with it, we'll figure out the compliance stuff later. In healthcare, people will just not deploy a system at all. Okay, unless this is solved, because regulators are already coming to them and asking those questions, and they have those contractual requirements. Okay, so this is basically as important as protecting PHI leakage from what we are seeing. Dramatic moment. Let's see how that works. Yes? Let's see. Okay, so for that, we have our nlptest library, which is separate. But let's talk about some of the actual use cases. So we have one payer use case, one provider use case, one pharma use case of people who are trying this out. So here's one of the largest payer, insurance companies. Everybody loves them. If you call your insurance company and you come and say, oh, I'm on the Arizona plan, I'm on the bronze plan, 1070X, I need to do a hip replacement, what's my copay? Right now, the support teams can take 10 to 20 minutes to return to the answer, because each of these documents, they're all public online, very exciting reading. Each one of them is about 100 pages long. But half of that is legal definitions, and then you have tables. Okay, and so, for this condition, and the condition is defined, it's like a one-page definition. In page 60-something, here is you have a 10% copy. And the question is, okay, can we just have someone read all of these, understand them, so they can just ask chat questions? And let's start with our own support team. Okay, so it's not even patient, but I won't support them, because then we can deal with some issues. The challenge here, you cannot just tune an LLM to do this, because you cannot tune an LLM all the documents. Each patient, only one document applies. Okay, and it has to be that exact document, right? Those numbers are different. The definitions are different. Those are legal definitions. The documents themselves, of course, you need to be able to kind of read them, and you need to do table extraction, you need to do OCR, you need to do those types of things. And when you answer, the answer is actually legally binding. So one thing I've learned for this, when you talk to your health insurance companies, always record the call, okay? Because what people do now, they do record the calls, and then if they told you something on the phone, later you get some other bill, you can actually tell them, it's like, no, that's not how it's gonna be. That can be the most important tip you learn this conference. So we need to be able to read specific documents and answer about a specific document in context. Missed one again. It's also one of the really largest pharma companies in the world. What they're looking to do, they have their products, which are drug, pills, and medical devices, and some vaccines. And they want to have a chat for patients. Okay, so a patient comes in and says, I was diagnosed with depression. What the hell is this thing, and what's going to happen to me, and what should I know, right? And then what are the, can you help me, and what does it mean, and what are the side effects? What else? How do I need to change my life? And if you have complex diagnosis, they do change your life, and you want to think about the whole thing, right? Can I keep working? Can I keep driving? How should I, what should I do? The only thing is, you definitely don't want answers to come from the, Medical College of Reddit, right? Or even from the National Academy of Medicine. If you're a pharma company, come and say, no, this is our product. Thou shalt only use the specific text from these approved documents. If you ever give an answer that's not from this approved text that passed through 7 layers of compliance, the company can be in hot water. Okay, so it's very similar in the sense that there are very specific documents that you're allowed to use, you're allowed to read, you need to understand them very well, and you need to be able to answer from them. Okay, and then what you do want to use the LLM for is you want to remove jargon, answer a different tone, like can you do this in Spanish, can you do this in Japanese, other questions. And of course, on the provider side, mostly what they want is to never use the EHR again, or basically it comes to anything that enables them to kind of bypass the many clicks right, that they need to do. So either just ask about my patient, okay, like who is this person, why are they here, what happened to them, I asked for this yesterday, did we get the test results? What did the specialist say? Can you please order this, order this test, order this prescription? This is stuff they often ask other people today in the team, but they want this faster this way. Similarly, you're asking about very specific document in a very specific context, very specific language. It has to be specific to the patient. It has to be absolutely correct, and you need to be able to explain it. And explaining is not just give me another text of the answer. Explaining means that once you have the answer, you can show links and references to each sentence. Okay, and then if someone says, oh, where did this come from? Oh, like here's the PDF, page 46, third paragraph, this is where I took it from. Right, or here's the table in this medical research paper. Here's the results, here's the number of patients who had this side effect. Okay, what we see, and we see it from our own doctors, this is super important in healthcare, because when people do question answering benchmark, it's, okay, what's the capital of France? Paris. Okay, good. That's not how questions work in healthcare. Give me all the high blood pressure patients. You give them the list. Why is this person high blood pressure? I don't think they are. Oh, because they had two measurements and it's 135. I tell you, no, I'm in geriatrics. Everybody's 135. Right? If it's not 150, don't even tell me. Okay, and then this person should we give them this medication? We can. Here are the side effects. What do you mean? Like, what do you mean these are side effects? These are non-side effects of this medication. No, I need to see the paper. Was this test done on 100 patients or on 10,000 patients? Is this a paper from 1998 or 2018? Right? What was the outcome metric? Right? What were the other conditions? Right? So you don't get black and white answer in medicine. Right? So a lot of what we are seeing is people, they want to read this. And then there's even a button that comes and now I want to chat about this paper. Okay, I have more questions. What did they do? Right? How did they assign this? What really happened there? And it's really this iterative context. Okay, but really the most important thing, for every sentence you say, you have to show them the paper and show them the results, which changes what the LLM does. Okay, so what you do, you're going to have multiple knowledge bases. So there are ones that we kind of curate and give. So we do all of PubMed, clinical trials, terminologies, ontologies, all of that. And then there's going to be your knowledge bases, right? So here are my patients. Here are my internal, clinical trial documents, research, lab notes, right? Whatever may be the case. And then, assign them to users and comes, oh, this group has access to these knowledge bases. This group has access to the other knowledge bases, right? And that's how you do kind of the role-based access and all of that. The way you implement it, and if you build something like this, you do this with what's called a RAG architecture, so a retrieval augmented generation architecture, which is kind of becoming a fairly standard thing in the LLM space, which means that basically you break the system into two parts. You have the front end, which is the chat and the query application, so that's when a user has a UI and they log in and they can chat with the LLM. But very importantly, the LLM does not actually provide the answer. Okay, and this is actually very important. All the LLM does is it forms a query to a knowledge base in the backend. Okay, and there's a lot of work in the backend where what you do, you ingest data. You do a lot of pre-processing, so we extract metadata. You do the information extraction parts that the LLM is not good at. You enrich it. You break it into sections in, like, not the way LangChain does just by section. Maybe you break tables, right? You break columns. You break it by the clinical note sections. You extract all of that, you combine it with other ontologies, you resolve it to codes, right? And then that is what you put in the vector database. And then when someone asks questions, like, I want all the people who have had a heart attack in the past 3 months but have not started on beta blockers yet. Okay, so you have questions and you combine, there's a temporal aspect, right? There's a medication grouping aspect, right? Because beta blocker is a group of medication. Heart attack is also, it's a bunch of conditions really. Put it together, find the people, bring it back. What the LLM does, it formulates the query. You send the query to the knowledge base. When it comes back, it's a UI element. It reformulates it as a nice UI, right? A nice bulleted list or a nice table. That's all it does. Okay, but what you want to make sure you do not hallucinate, you tell, look, if I ask you what is the capital of France, if you don't find the paper and the page that says what the capital is, the correct answer is I don't know. Okay, and this is the key thing that you want to ensure, right? So that it's only the documents that are there, only the documents you put and process there, only the most recent ones. And then, of course, one advantage is you can update it in a real-time basis. You don't have to tune or retrain your LLM, right? So it actually becomes much cheaper to operate, right? And all of that you put within one Kubernetes, one box. So you can actually, you can deploy it on-prem, you can scale it as you want, but kind of it's one single platform. And with that, there's one other problem we had to solve, and the way we solved it is with our open source library, so that's another thing you can just take in use today. When you build these kind of RAG applications, one of the things that you have to do, and this is kind of really a fairly standard kind of diagram now, is you take all the documents you want to index, you do some augmentation, information extraction, but then you calculate embeddings, right? So you calculate sentence embeddings or paragraph embeddings, right, depending on how you break those documents. That's what you store usually in some vector database. And then when there is a query, right, so you come say, show me all the videos of kittens. You basically translate that to an embedding. And what you tell, and this is really the one trick that vector databases do, is that they can very efficiently and at scale do this query where given this embedding, give me the most similar embeddings in the whole database to this thing, right? That's the one trick. Okay, and then you get it back, and then the LLM can come and say, okay, I have these 5 references or 5 paragraphs that you gave me. I'll put it together in some bulleted list, I'll dedupe it, and show it to the end user. What this means is, especially if you have many documents, and for example, one of the first issues we had, we said, we need to do all of PubMed. All of PubMed is 34 million documents, and growing by the month. You cannot even do it with the standard libraries that are there. A lot of what you do today, people do thousands or at most tens of thousands of documents, and there's even a problem with just long documents. So in terms of time and in terms of cost, just calculating these embeddings is going to be an issue. What people do is they scale this through parallelism, right? So if you have a PDF document, and this is one example from the AnyScale blog, come say they had a specific, fairly short PDFs. This it was a few pages, so it's 7.5 seconds to parse each one. I can tell you, we're working with cancer patients. You have 1,000 pages per patient, right? Or you have clinical trial results that 100 pages, 200, 300-page documents. So you can take tens of seconds per document. You can't do a million documents this way. You can't even do 10,000 documents this way. So what you do, you can parallelize it. Okay, which is well, it's one of the things that Ray does really well, namely to do this parallelism. And definitely, if you're interested in that. The Ray solution integration with LangChain, it's completely free, open source, definitely one of the things you should look at. When we started looking at this, we said, okay, this still does not solve 2 problems. One problem is, okay, what about just speed on one machine, right? So there's 7.5 seconds if we multiply. Can we make that maybe 2 seconds, 1 second? Okay, because right now, most of I think probably most, if not all the embeddings, basically use Hugging Face as the implementation. And what we do have with Spark NLP, we have a completely separate code base and implementation. One of the questions was, can we just do that bit significantly faster? Okay, just as a different, faster implementation. The second was, what about a more complex processing? So one thing is come and say, this is what LangChain Haystack do really well, is you take the text, break it into some heuristic, and you just calculate the embeddings. In healthcare documents, it's generally not enough. So if it's clinical text, yes, I need to de-identify it. Then I need to do entity recognition from clinical entities. I want to do some relation extraction. I want to do some negation. I may want to map it to standard codes. Then I want to deduplicate some of the results. I want to probably normalize dates, right? Those kind of things. And then I have something that I can store. Okay, if it's biomedical research, it's a PDF. Oh, I need to do table extraction, right? I need to maybe even want to look at the figures and extract from that. I want to break sections. So it's much more involved, which means that really you need to be able to do this much faster. So our open source team for Spark NLP took the challenge and said, like, we got this. So everything I'm showing you for now, it's Apache 2.0 license, completely open source. And what we started was, okay, can we take current embeddings, and and of course it needs to be state-of-the-art, interesting embeddings, and just be able to do them and start with, forget scaling, single machine, can you do it significantly faster than Hugging Face? And I'll show you some of the metrics. So this is one benchmark. This is like fresh, this is from last week. This is single server, it's a specific HP server. It's there also, all of these, the notebooks are public, so you can run them on your environment, right? You can see how it works with your own caching, memory, however you set it up. This is all on CPUs as well, so it's fairly cheap hardware to run on. And we can see that on the optimized, non-quantized embeddings, I mean, you get the exact same accuracy. You actually get the exact same numbers. So it's exact same embeddings. We can be usually about 3 times faster than Hugging Face on a single machine, which can be very significant. You have a scale. Really, this is where most of your money and time will go. If you use the quantized version, it means you lose about 1 or 2 points of accuracy, but you have a much smaller model. You can easily get to 6 or 7 times faster than the Hugging Face implementation. We run similar things within Databricks. Okay, so also if you want it, you do import on Labs. You just on the open source, use the embeddings running on Databricks, so we see similar things. 2x if you're really staying just single node, a small node. You can go up to 7x if you use the quantized version, and which basically enables you, with the same memory, enables you to run more, use more threads. One other thing we saw on Databricks, and that's really what started us on this path. When we got to 100,000 sentences, 1 million sentences, you just literally could not run it. Okay, one of the reasons why you would see people scaling embeddings, okay, is because really, if you try and this is look, these are 100,000 sentences. Okay, it's not a lot, right? It can be like 20, 30,000 pages of text. Okay, it can be even like 10,000 pages of text. It just completely breaks out of memory, right? On beefy machines, right? Machines with a lot of memory, and we've tried it, quite a lot. We actually worked with tried to work with Hugging Face team to see what we can do. It just does not run. With Spark, we were able to run up to 1 million. Even if you work on Colab, on 16 gigabytes memory, with the cheapest CPU and 2 cores, you can still get, depending on what you do, about 2x speed. Okay, so that's available to you as well, right? And that's really just kind of, it's a one-line installer and it just works. But then if you're looking at it from a production deployment perspective, the other important thing here is the ability to scale. And one nice thing about Spark NLP is that it natively scales, right? And it's designed from the ground up to do it. So you don't need to integrate a new library. You don't need to learn a new API, right? You don't need to think about how all of that is going to work together. You actually don't have to change even one line of code. Okay, when you load it, you just come and say, look, it's the same thing that I ran on Colab, just run it on this Spark configuration, and now I want you to just whatever, put it on 12 machine or 16 machine, just see, just run it. One thing you see, we are very close to linear scaling here. Okay, because really, it's not a hard problem to linearly scale. You just do the documents in parallel. But the point is, this actually works, and if you know anything about distributed computing, it's actually hard to get this thing to work in practice. And you can see what happens on 5,000, 50,000, 100,000, then 1 million sentences. So 1 million sentences, which I say 1 million sentences, like we process much more than that, and we see more than that. 1 million sentences is not that much. It can be 10,000 patients a day, which is probably what you have in radiology in a large healthcare system. And this is just a Spark NLP number, right? So the Hugging Face numbers are like 3 to 7x longer than that. But on Spark NLP, just one node took 48 hours. 0 code changes, you can take it down to 3 minutes. Okay, which also means the 3 minutes version that you scale is actually cheaper, right? So because you pay for DBUs, right? You actually have less compute running here, okay? Because you have 16 machines, and you're more than 16 times faster here. Okay, so what this means is that, that works, available, kind of that problem is solved. Of course, in terms of the actual embeddings that are there, the sent embeddings, document embeddings, they're public leaderboards. Right now, we are at the point where the open source embeddings are actually outperforming the OpenAI ones, right? And that's kind of in the last few weeks. And the two top ones are actually included with Spark and LP5. So if that's what you need, that's kind of that kind of comes with it. And that's, as I said, completely free and open source. And with the healthcare, of course, we have healthcare-specific embeddings, but that's kind of part of the healthcare package. So that's what I want to cover. Last thing I would say is there's a lot of stuff that's open source. On the stuff that's not open source, my goal was to just share, here's the solution architecture, here's how we do it, here's why we do it, so that you can tell me where I'm wrong, and we can learn together. Thank you.